Hello, this is Rick Guptill, and this is a demonstration of strucim welding. In this case, we have two different types of welding work cells that we can load depending on which part we're going to use. And this is actually for welding thin-walled steel framing structures to make wall panels and uh, floor panels. These files that we're getting are actually XML files, although we can read many different types of file types and extract the weld information. These XML files contain ACES shapes and weld information. You can see the welds right here. And there are different types. They're color coded to the different types. There's the lap weld, the vertical welds, and then this is a bevel weld down here. So what we do is we get the welds kind of generically, just as their position, and then we go through and we find out which two shapes, which two beams, which two framing structures are going to be welded, and we look at the normals of those and we bisect them so that we get a reference frame on how we're going to weld this. Okay, we might not weld it at 45, but at least we have that represented here. So this panel here, there's 216 welds. It shows all the different welds. The yellow is where we start, and then we're going to go through the red. This is a lap weld here on the top, and then these are vertical welds, and then here's a bevel weld down here. We're just going to concentrate on those because these are reproduced over the entire panel. Each weld type, so this is a certain weld type, contains a way to touch. In this case, we use a laser scanner. This is a Kawasaki robot on a 2-axis gantry. There's a big long axis and a cross axis. So what we can do is actually we can define how we want the laser, what position we want the laser to be in for the touch. And this is what it's figured to be. And this is the touch position, and then there's a near approach and a high approach. And then we use those touch positions to the touch moves. We select that side 2 in this case, we call that. And then we define safe elements, which are they move the gantry, they move the robot to get the robot in and out of touch positions and weld positions. There's weld JVs, touch JVs. And then we have a series of safe moves where we have a pre-touch and a touch, and in between those, a pre-touch and a post-touch, in between those the touch will happen. And then we have a pre-weld and post-weld, and in between those the weld will happen. And then the weld, actually, we can look at here, we can put in manual components of what we want. Like, for example, this is a weld with this is a 60-degree angle torch, so this is at 55, it tilts a little bit in. If we change this to 60, you can see that the torch is straight up and down this way. But we like to sort of, we can see that the laser is going to intersect it here. That's why we're adding a little bit of a push to kind of move that back a little bit. And then we find that if we, in this case, we specify this as the work angle, it produces a good weld because it's got to get inside this bevel. The real part is curved down here. So you can either select a manual, like these are the parameters I want to use, or you can select auto and you give it a range, and strucim will find a collision-free place to do that welding. Okay, so we're ready to plan these welds now. So we're going to plan these welds that we were just looking at. We're going to say we're ready to weld those, and we'll let strucim compute the welding paths and the touch paths. We've taught all the touch paths, and we've told it how to weld. In this case, we can't perform the weld on the very top because there's a collision. And then these vertical welds, we group these together to make it more efficient, and so we scan, weld, scan, weld, scan, weld these, whereas most of the welds you have to have a safe move to enter and then a safe move to leave. Then we also see that it detects that it can't actually touch that bottom weld, the vertical weld, without a collision. So we can't perform these 2 welds, but we can perform these 5 welds. Okay. So we then would save this out to a file, and it creates the Kawasaki robot code that then you can run on the real machine. And you can see here these are the possible welds. Here's the code that's generated, and these are the 3 welds. Remember, the vertical welds are combined into 1 weld. And then this is the program for weld 1, weld 2, and weld 3 down here. So let's just start this running. And then you can see here, let's start this running. I want to slow this down so that we get a match here. Okay, so now we're doing the first vertical weld here. So this is the actual code that then is sent to this robot. And then we do the scan. Okay, now speed this up just a little bit. Trying to match them, although it's not really necessary. Simulation is just used to plan the path and look for collision-free path, and then the real velocities are used depending on the type of weld parameters that are stored in the robot. Then we go down and we finally weld that bevel weld. When the gun turns violet here in simulation, it's actually welding there. All right, let's go. Let me know if you have any questions. Thanks.